Okay, you see that angle at the top of the triangle there that's moving around inside the circle? It's constant. It's staying the same. Now that's called the Inscribed Angle Theorem. Let's see if we can get an intuitive understanding of why it's staying constant. Why is this true? Well, because it's inside a circle, we can draw on the center and the lines from the center to each of the corners, and each of those lines is a radius of the circle. That means they're all the same as each other. So here they are, and they're all the same. Now notice that each of those triangles has two of those radius lines as two of its edges. Okay, so this blue one has those two, green one has those two. That means that each of these triangles has two edges that are the same lengths as each other, which means they're isosceles. Now isosceles triangles have this nice property that the base angles are the same as each other. So those two red angles are equal, those two blue angles are equal, and those two green angles are equal. Now if you take them all together, they fill up the corners of that big triangle. So altogether, these all add up to 180 degrees because the angles inside a triangle add up to 180. All right, now let's have a look. Well, some of them are changing, some of them are not. Okay, but we've got three equal pairs of angles. So 2 green plus 2 red plus 2 blue is 180. Now, let's have a look at that blue triangle there. That part is not changing. Those blue angles are constant because that chord at the base is not changing. So we have that 2 green plus 2 red plus 2 blue is 180, but the blue is constant, so 2 green plus 2 red plus a constant is 180, which also is the same way as saying that 2 green plus 2 red is 180 minus a constant, which is also a constant. Okay, so we have that 2 green plus 2 red is a constant. Well, we could call that 2 times green plus red is a constant. But wait, what is green plus red? Green plus red is just this angle at the top of the triangle, the one that's moving around. So even though green is changing and red is changing, green plus red, which is that angle, that inscribed angle, is staying constant. So that's why that inscribed angle is constant. That's why the inscribed angle theorem is true. And that's what we were trying to prove.